Good afternoon, everyone. Welcome to the Virtual Conference 2024. We've got Mike and Sam from IBM to talk about the communication server in 3.1. Sam, do you want to take it away?
All right, thank you. As he said, I am Sam Reynolds, and I'm joined by my colleague Mike Fitzpatrick. We are both architects for zOS Communication Server, and today we're bringing you an update on the contents of Communication Server in zOS 3.1. So here's the agenda. I won't read through all the bullets, but as you can see, there's quite a bit of information here, quite a bit of content that was in 3.1. Some of the content was also rolled back as part of continuous delivery to earlier releases, and we will identify those items as we get to them. I'll point out that the appendix has a little bit of additional information that we won't be covering during this presentation, but it will be in the PDF. And having said all that, let's just get started. The first area we're going to discuss is enhancements in the area of network security, and there's several here to talk about. The first one is called FTP Server JES Access Control. So the zOS FTP Server has had for many, many years a rather unique capability to allow for FTP-based remote job entry to zOS. So if you put our server into this JES mode, as we call it, all of a sudden, instead of it put command from the client being putting a file onto the server and a get being retrieving a file, now you're talking about putting a job to the server, the JCL for a job. When you do a get, you're retrieving job output. When you do a dir, you're listing the status of jobs. So this is a fairly interesting capability. You see some bullets there to describe some more information. Basically, what I would point out is there's a FTP parameter called JES interface level, which determines whether FTP users have access to jobs matching their logged in user ID plus one character, or broader access, which is the level equal to parameter. There's also a few other operands, JES job name, JES owner, and JES status, which you can set via site commands to control what jobs you're actually looking at or working with. So just to kind of give you a quick example here, if you do a dir, normally what you normally think about you doing with a server, you'd be listing files. But in this case, we've started by doing a site command file type equal JES to tell the zOS FTP server to go into JES mode. We've set a filter to say we want to work with anything called test job, maybe with an extra character. We do a dir, and now we see a list of job output to all jobs, test job something. So very different capability. We have a lot of customers that like to use this. It's actually a fairly popular feature. So what's the problem? What are we here to talk about? Well, a few years back, a number of security pundits began to express a little bit of concern over this interface. They felt like it represented a particular attack vector, the idea that you would let someone come in and submit a job or retrieve job output. Now understand, you have to be a logged in user. So you have to have a user ID on zOS and log in under it. But still, there was some concern expressed. And there are classes from that JES has, JES jobs and JES pool, that you can use to control this to some degree. The FTP server on zOS provides a number of security exits, and I showed a couple of relevant ones here. But for example, the FTP check command exit is our security command exit. And you could write a little piece of exit code that basically catches the inbound command into the FTP server, looks to see if it's file type equal JES, and if so, rejects it. With that one action now, you've prevented anybody from going into JES mode. So if you were worried about this, that is a way to turn it off. There's two problems with that solution. One is it's all or nothing. If you want to be able to allow yourself access and maybe a couple of other administrators, but no one else, that's more complicated exit code. The other probably bigger problem is that most of our customers in this day and time do not like to write exit code. So they would rather have an easier way to control it. And in fact, an RFE was submitted several years ago when we moved to AHA, it became an idea. And at the time that we addressed this, it had 54 votes, which at that time made it the highest voted requirement against communication server. So what did we do? Well, we created a serve-off class resource that you see the name of there, ezb.ftp.sysname.daemonname.access.jez. This allows you to explicitly control access to JES mode. If a user has permission to that resource, they can go into JES mode. If they don't, entry to JES mode is rejected. So fairly simple to set up and use. Note this is not a replacement for JES jobs or JES pool. Those have broader use beyond this and are still useful. We've felt there was such a demand for this function, and it was such an important function that we rolled this back very early in 3.1. You see an APAR number on that top bullet. We rolled it back to 2.3, 2.4, and 2.5. And this occurred about 2 years ago. So that APAR has been out there now for quite a while. And our recommendation is this is probably something good to do. If you're not interested in JES mode at all, you can easily disable it. If you want to have access to a few people, then set it up as a UAC none, and then permit individual users as you see fit. So new function, highly recommended. The next topic we'll talk about is ATTLS currency with System SSL. So application transparent TLS. Hopefully everyone that's watching this knows what that is. We shipped it back in V1R7, so about 15 or so years ago. It's been around a long time, and we believe that most of our customers use ATTLS to protect their traffic, their TCP traffic. The thing is, every release pretty much, System SSL makes changes to TLS. And if they make a change, there's a really high probability that our ATTLS policies and the network configuration assistant code has to be updated to stay current with the changes System SSL makes. So if you look at one of our update presentations for any release since V1R7, there's a real good chance you saw a line item in there with this name. Of course, it changes every release what we're doing depending on what System SSL is doing. So in 3.1, System SSL added support for X25519 and X448 elliptic curve key exchange for TLS 1, 1.1, and 1.2, and also provided an option to limit the TLS server's allowable elliptic curves. Since they did that, we have to do the corresponding support in ATTLS. So this is the same set of bullets, really. It's just saying that now ATTLS allows you to do the same thing through our policy statements and through the network configuration assistant. We did roll this back to 2.5 only. It was rolled back about almost 2 years ago. It was in August of 2022. So this maintenance has been out there a while if you're interested in this capability. Now, something else that System SSL did in 3.1 was handling Sysplex session ticket caching for TLS version 1.3 on a Sysplex-wide basis. So TLS version 1.3 supports session resumption in a different way than we did with TLS 1.2. That we use these session tickets that contain all the information the server needs to resume a TLS version 1.3 session. The client caches a one-time session ticket returned by the server, and then that can be used to perform an abbreviated handshake when you reconnect to the server. So this can have performance advantages. It's a nice thing to do. Well, we supported TLS 1.3 beginning in 2.4. That included the use of session tickets for session resumption, but that only worked within the scope of a single address space. There was no Sysplex-wide support because System SSL did not provide that either. Well, System SSL adds that support in 3.1. And so that means we need to expose that capability through our configuration parameters. And you see those listed on this chart, along with the fact that those are coded. You can code those manually in policy, or you can more likely code it through the configuration assistant. Speaking of that, we get a lot of questions around TLS performance. So if you're talking about 1.2 to 1.3, what's the performance difference there? If you're thinking about session resumption, is that a good thing? What does that buy me from performance perspective? If you're interested in what does this cipher suite versus that one mean from a performance perspective, those are all good questions. And a colleague of Mike and mine, Christopher Nyamfel, very recently, about a couple of months ago, published a white paper on TLS performance, and you see the link there on your screen. This is an excellent paper with a lot of very useful information. I highly encourage you to download it and take a look. And the last enhancement from a security perspective I'm going to talk about is Xert Network Analyzer Enhanced Upgrade Support. So if you've seen a CommServer update presentation in the last 3, 4 years, you've seen this chart. Probably sick of seeing it. You've seen so many times. But what this chart is saying, zOS provides 4 mechanisms to cryptographically protect TCP/IP traffic. You can directly use the system SSL or JSSE APIs. There's application transparent TLS, which we already mentioned. We think most of you use that. There's also IPsec, which is encryption at the IP layer, which can be used to protect anything above it. The first 2 mechanisms, 1 and 2 there, are TCP only. And the 4th mechanism we're going to mention is TCP only as well. IPsec can protect anything, and that includes UDP. That can be important because many of you use Enterprise Extender to protect your SNA traffic, and that is a UDP protocol. So you must protect it with IPsec if you're going to protect it. And then lastly, secure shell using zOS Open SSH. Now, that's not a comm server thing. That's part of zOS, but not communication server. But it uses the TCP protocol and goes through communication server. And the big use case for that is SFTP, secure file transfer, not to be confused with FTPS, which is zOS FTP protected by TLS. So 2 different protocols, both accomplished file transfer in a secure manner. So what's the issue here? Well, which of these mechanisms does your shop use? You probably use multiple of these mechanisms. If you have Java apps, you're probably using that first path. Hopefully you're using ATTLS, and we think most of our customers do. That's the second path. If you have SNA in this day and time, you probably have EE, and if you're protecting it, you've got to use path 3. And lastly, a lot of shops have a mandate that for secure file transfer, you must use SFTP, which is path 4. So it's entirely possible that you're using not one of these or even 2 of them, but 3 or even all 4. Well, that's a complex picture. So how do you know that you've got it right, given all these mechanisms? How do you know that it's all right today? And as you roll out a new application, you may have to adjust and add new parameters and so forth. How do you know that you're doing all that correctly and that you have the information that you need to prove to your management and to auditors that all of this is configured correctly? Well, that's where ZERT comes in. ZERT was introduced several years ago, and the first wave was called ZERT Discovery back in V2R3, and introduced these things called ZERT Connection Detail Records, SMF 119 subtype 11. So these records describe the cryptographic protection history of every TCP and EE connection, and we'll write out at least one of them for every connection. Well, that's a lot of great detail. It's also a lot of SMF volume. So pretty shortly after we shipped to ZERT in 2.3, we followed with a function called ZERT aggregation, which introduced subtype 12 ZERT summary records, which describe the repeated use of security sessions over time. There's a single ZERT summary record at the end of every recording interval for every security session. So if you have 1,000 sessions between a client and server with the same security characteristics, instead of getting 1,000 subtype 11 records, you would get a single subtype 12 record per recording interval. Lastly, since we gave you all of these new SMF records, how do you want to analyze those? Well, the vendor community has a number of products that will consume one or both of these types of SMF records and do stuff with them for you. We in zOS wanted to provide our own capability, so we provided the ZERT Network Analyzer. The ZERT Network Analyzer is a zOSMF plugin which consumes subtype 12 SMF records, stores them in a DB2 for zOS database, and then gives you a GUI that allows you to write queries to work against that data. So for instance, you could write a query that says, show me all my TCP connections that are protected by TLS, but at a level less than TLS 1.2. So this gives you a way to identify the connections you have that might be either not secured or secured at a level you would consider very weak, and you might want to take some action to improve on. So nice function. What's the issue here? Well, we've been told by our customers that when upgrading ZNA to a new release, that there's a little bit too much manual effort involved. There's database connection settings, there's application settings, and those have to be manually copied from one release to the other. And you have to create a new ZERT Analyzer database. You can't reuse the existing one. So what we did in 3.1 is to try to make those jobs a little bit easier. You see a panel up there on the right that allows you to import or reset your application settings. So it shows you what the application settings were in your current release and what the default settings will be, and allows you to choose which you want to apply to your upgraded release. This is for application settings. There's a similar panel that will come up to help you set the database connection settings based on your prior release settings. We also provide new DDL templates to facilitate migrating ZNA to a current schema level. So this hopefully makes it a lot easier. If you're, say, 2.5 today and you want to move to 3.1, that should be a much better migration experience than we've had in the past. And here's just kind of a nice reference chart. And when you get the PDF, the most important thing is going to be that link that's underlined toward the bottom of the chart, things you should know about ZERT. That takes you to a page on the IBM community that has a wealth of information about ZERT, blogs, videos, documentations, and so forth. So highly encouraged, something to look at and bookmark and save and reference later. At this point, I'm going to pass this over to Mike, take you through our next topic.
All right, thanks, Sam. So the first one I wanted to talk about is some enhancements we did to our syslog-d daemon that runs on zOS Unix. First of all, just a little background for those not familiar. Hopefully most of you are. What syslog-d is, it's just a syslog daemon. And what it is, it's just a process that's going to run directly on zOS Unix. And any applications and components typically that are running in that same on zOS Unix as well, they can use syslog-d for logging any type of messages or capturing any type of debug information that's needed for later troubleshooting. It's a standard that, is also available on, Linux and other Unix type platforms. And it's essentially just a way to kind of, for applications to have a common place to log their messages and debug. How syslog-d is controlled is really by defining rules in a configuration file called syslog.conf. And there's two types of rules. The first type of rules is really to define how messages and debug information are received by syslog-d. So there's two ways of doing that. Local applications that are running on the same system where syslog-d is running, they use something called a syslog API. And essentially that's like an AF Unix socket, which is a memory-to-memory communication between the different address bases where the application is running and where syslog-d is running. There's also a way for syslog-d to be configured so that it can receive messages from remote hosts. And those are remote hosts are running syslog-d as well. So those messages from remote hosts can be sent to this single host syslog-d instance running on this host in order to consolidate messages. So just as an example of that, if you have like many systems in your data center or in your sysplex, and they're all writing to their own copy of syslog-d, it becomes difficult to try to manually consolidate or gather all of that messages and information if they're scattered across all different systems. So by configuring to kind of consolidate all those messages into a single syslog-d instance, now you have one place to look for all the messages that are getting generated by applications in your sysplex or in your data center environment. The other type of rules that are configured is once the syslog-d receives messages, either from the above two scenarios, either locally from applications running locally or from other syslog daemons shipping their messages over, what do you do with those messages? Well, there's several different options for that as well. One of them is that they can get written to local files. Now, those local files also, there's inside of our syslog-d on zOS, we have the ability to, set up archiving. So after so many days or after so many bytes are written into the file, we can basically archive a copy of that for later retrieval. So there's a lot of advanced, nice archiving and capabilities there. The other thing you might want to do is to be able to record these messages in SMF. It's not recommended you record every message that's getting written to syslog-d to SMF, but there may be specific applications or specific types of messages you want to record for auditing reasons, whatever the case may be. And then the final rule is essentially saying, well, if messages come into my instance of syslog-d, maybe there's another place where they all get consolidated, and you can basically specify the remote destinations you want to send those messages to. So pictorially, how does this really work today? Well, so for example, you might have a zOS host, and there's a set of applications running on that host, and it is using an AF Unix socket to talk directly to syslog-d using that syslog API. You may have another set of remote hosts anywhere, and these could be zOS hosts, these could be Linux hosts, Windows hosts, it could be any host that actually also runs syslog-d. And in this case here, the applications running on that those remote hosts talk directly to their local syslog-d, but that syslog-d is configured to ship messages over to the syslog-d that's running on the zOS host to consolidate things. As you can see, it is using UDP. That is the default, and that's what zOS prior to our support was the only thing that it supports is the UDP protocol. You also have remote destinations that may be also consolidating other types of messages so that the zOS host here on the upper left could also, now that syslog-d could also be shipping some of its messages via UDP over to the syslog-d on these remote destinations. Now, as mentioned, this is only UDP, and what that is an unreliable transport. TCP is reliable and guaranteed message delivery. UDP is best effort only. So if any messages get lost in transit, those messages will get lost. In addition to that, when Sam was talking about TLS, TLS only applies to the TCP protocol. So in order to secure these types of messages, you're going to have to be able to create a virtual private network using IPsec between the zOS host and all the remote hosts. So what we did to kind of overcome these kind of limitations of it is new in 3.1, and we rolled this back to 2.5 as an APAR as well, is taking this same picture. Now when you configure whether there, where from your zOS host, what remote host you want to have send messages to you, or what remote host you want to send messages to, you can specify what transport you want to use in this configuration file. So you can, by default, it will still be UDP, but you can configure it to say, I want to use TCP instead, which will now give you this guaranteed delivery, and you will no longer have potential message loss. In addition to that, you can also configure to say that it requires encryption of the traffic between the syslog-d running on each of these systems. And from a zOS side, we rely on ATTLS for it. On the remote destinations, if they're non-zOS, they would have their own native implementation of TLS. But essentially what syslog-d will do in that case is it will ensure that there's ATTLS policy and rules in place to encrypt the data. So now you basically have the ability to have more reliable message delivery and better or easier to set up encryption using TLS. So again, that's in 3.1, and we rolled back to 2.5 as well. The second thing is we wanted to talk about is we announced last month something called the zOS Container Platform. And before I jump into that, essentially what it is it's the ability to run native zOS Unix applications in a containerized environment directly on zOS. So how do we do that? Before we do that, I just want to try to give an evolution of application development. So 25, 30 years ago, applications were written and they run on a single host operating system. They share all resources with other applications running on that same host operating system. There's no isolation between them. They share the same network. They share the same file systems. They share the same libraries, etc. So there was no real isolation between them. Then came around virtual machines. Now, from a System Z standpoint, we've had virtualization for many years with ZVM and our hypervisor, our Prism hypervisor that allows you to IPL multiple guests on top of a single system. VMware also made it very popular on distributed systems. And essentially what you have there now is you basically can run your application in its own virtual machine, which is essentially a complete operating system with all its libraries and dependencies that the application needs built into this virtual machine. So you do get all this isolation, but it is quite heavyweight. Everything really is running an entire operating system inside of each of these virtual machines. So that's when containers came around, and that probably, really came into play, 10, 15 years or so. And essentially what that does is it's essentially a lightweight implementation of a virtual machine rather than having to have the entire guest operating system built into the virtual machine. These containers will leverage the existing host operating system, but take advantage of things within that host operating system kernel to provide types of isolation. For example, file system isolation, network isolation, process isolation. So these containers, even though they're running and sharing the same operating system, they are running completely isolated and independent of each other. So it's a very powerful technology, very useful for things like microservices and stuff where you want to spin things up very quickly or take them down. Containers can, you can spin them up very, very rapidly and take them down very rapidly as well. So it's a very powerful technology, widely used throughout, most, the distributed and other platforms. So we wanted to bring that to zOS as well. So that's what we did. We announced in GA in last month, support for containers running directly on zOS. So what that means now is using Podman, which is a container CLI that basically manages the life cycle of a container. You can now containerize and build zOS Unix applications into a container image and deploy them as container directly on zOS. We also have a statement of direction that we did to basically say, in order to support orchestration of these, we will also be providing support to have Kubernetes management of these containers in a future deliverable. So first question you might be asking, well, don't we already run containers on zOS? And the answer is not really. We do have something called zOS Containers Extension, which allows you to run containerized Linux on Z applications. And the key there is these are Linux applications that could run with the S390X architecture, and you can run them either on a system that runs, Linux on Z directly, or you can run them inside of ZCX, which is essentially an address space that runs within zOS that hosts a Linux operating system along with Docker, so that you can actually then deploy Docker images directly inside of that zOS address space. Very powerful technology, but it really is limited to Linux on Z applications. They have their orchestration is something called Docker Swarm, which is essentially an ability to group together multiple container images into some type of a clustering environment. They also have something here on zOS that we call ZCX Foundation for OpenShift. It's essentially the same thing. We're still running containerized Linux on Z applications within an address space within zOS, but rather than using Docker Swarm as the orchestration, we're using OpenShift, which is basically built on top of Kubernetes. So it's a Kubernetes cluster with the OpenShift infrastructure built on top of it. But again, this is to run Linux on Z applications directly on zOS within a zOS address space. So the zOS container platform, what we did there is we've taken it now, and it's no longer Linux on Z application, but these are zOS Unix applications. So think of your Java applications, or your zOS Connect applications, or your Go applications, etc. What you'll be able to do is you're going to be able to containerize them and run them directly on zOS via Podman. In addition, as I mentioned in this statement of direction, we will be providing Kubernetes orchestration. So the same tools and everything that you use for other platforms for deploying your workload and monitoring and managing it, those same tooling and look and feel will be available to you on zOS via the zOS container platform. So now you may be asking, well, why Why are we talking about this for a communication server update? Well, one of the key things I mentioned about containers is isolation. And one of the main isolations that is required for containers is network isolation. So essentially what we've done here is what we want to talk to you about is some of the enhancement we've done in communication server in order to support this network isolation. Containers have a standard called this Container Network Interface, or CNI, that is a specification for how containers get IP addresses and return IP addresses whenever a container image gets started or stopped. We are following that to the letter so that container runtimes such as Podman or Cryo that is being used under the covers by Kubernetes can directly call these CNI to retrieve IP addresses. Now, on other systems, on distributed systems, when a Podman run command is issued, for example, for a container image, an IP address gets assigned to it. This IP address is a private IP address that is configured as a pool of IP addresses available to Podman. These IP addresses are not accessible outside this system. What happens is Linux has these translations, these layers that basically convert the private addresses to real addresses and vice versa whenever it needs to communicate externally. So there's this additional hop in order to basically do this translation. Similarly, for Kubernetes, when you do a Kubernetes apply of a deployment, essentially that kicks off a set of pods. Again, that will pull from a private IP address range that is not externally accessible. And they also have this layer that basically provides this translation between private and real addresses. On zOS, we did not want to actually do that. What we decided to do is we wanted to leverage our existing dynamic VIPA capabilities we have by being able to dynamically create virtual IP addresses on the fly whenever a container gets started or stopped. So we created a new VIPA range statement that has the keyword zcontainer on the end of it, which essentially says this range of IP addresses is reserved for anything that's running as a container on zOS. So when we do a Podman run on zOS, when it pulls an IP address, it will pull an IP address from this VIPA range dynamic VIPA statement and dynamically create that dynamic VIPA. Now you have the flexibility now of either this could be a private internal address if you want, and you would set up routing to basically reach it, or you can make it externally available and you basically define this subnet to OMP route and you could advertise it. So you get the flexibility or the benefit of both worlds. You can either continue to make them private or you can have them be external as well. And same thing when you run Podman on another system, it will have its own different range of IP addresses defined to it. So we have the capability now of basically using dynamic VIPAs, using our existing VIPA range technology to reserve a range of IP addresses to be available for containers when they get started. Same thing for Kubernetes when we start releasing this Kubernetes. And Kubernetes consists of what's called nodes. There's a control plane node, which is really the brains behind the system of the cluster, and then a set of worker nodes where the actual deployments happen or the container images get run. That control plane node, what we've done here is we're actually going to be creating a new type of appliance that essentially is running Linux within an address space again on zOS. It's going to have all the components to make up a control plane. So there's a lot of complexity inside that control plane. We're essentially making it just a single appliance that there's very little configuration required in order to be able to use it. One of the configuration pieces, though, is we need to be able to assign an IP address to this control plane node. And so we're creating a new type of VIPA range statement called a ZCPA, or zOS Control Plane Appliance VIPA range. And these IP addresses are reserved only for these appliances. The actual pods that get run or container images that get run on the worker node, they're going to be pulled from the same range that is shared with Podman. So that same zcontainer VIPA range that we talked about before for Podman applies to this as well. So that's all coming, the Podman support is here now. The Kubernetes stuff is coming soon, but there will be specific network changes in order to be able to provide this network isolation. Okay. The next piece I wanted to talk about, a function was something called persistent pause support for Sysplex distributor devices. Today, you're probably all familiar with Sysplex distributor. You configure it on one system, and then you set up a set of target stacks that connections can get sent to. So for example, a connection comes into Sysplex distributor on target 3, and it gets forwarded over to target 4. All makes sense. We also now have this existing capability of the ability to temporarily take a target out of the Sysplex distribution. For example, you may want to bring that first system on the left down for maintenance and bring it back up. So you can issue a quiesce command directly on that system to basically tell Sysplex distributor, send no new connections over to that target. It's temporarily quiesced. When you're ready to allow that target to be a system to be a target again, you can issue this very Sysplex resume command. Pretty much, this is existing technology. It works very well. But what are the drawbacks of it? Well, one of the drawbacks of it is there's no way to preserve that quiesce distribution status for a target. So for example, once you issue that quiesce command and that target is quiesced, if you bring that application down and back up, or if you bring the target stack down and back up, automatically we've lost knowledge of that quiesce state, and that target immediately becomes available again for distribution. That may or may not be what you want. So what we've done in 3.1 is created this new persistent quiesce of Sysplex distributor targets. So what we do now is you have the ability to configure in your Sysplex distributor configuration at startup, before you start the TCP/IP stack, you can basically say, what do I want the state of my Sysplex distributor to be in? By default, it's going to be the same behavior it is today, where it's immediately available, but we can also configure it now to basically come up in this pause state. That means that while it's paused, no targets are going to be able to receive connections. You could also dynamically pause it using this very Sysplex distribution pause new keyword that basically said, don't allow any targets to receive new connections. Let existing connections finish, but drain everything else and prevent any new connections. You have the resume to basically now resume it again. Now, the question might be, why would I want to use this kind of technology? What are the purposes of it? Well, there's a couple of reasons that customers have asked for this. One of the reasons was that sometimes when applications come up, they immediately will listen on that Sysplex distributor port and immediately become eligible as a target, but it might not be completely ready to accept connections. For example, it might have some reliance on some internal database it's using or some other type of config file it needs to process. And so we want to be able to control when that target becomes eligible again. So by using this distribution, by this persistent quiesce of Sysplex distributor targets, you get to control when those targets, even though they come up, you control when you want to have work start getting distributed to them. And it persists across IPLs, et cetera, with this new statement as well. So that's kind of one of the main use cases for this. There are others as well. For example, when you want to bring down an entire Sysplex and bring it up in another site, for example, you're practicing your disaster recovery procedures. In that scenario, you may want to completely quiesce that Sysplex distributor on your production site. Later on, you bring it up on your backup site. When you bring your production site back up, you immediately may not want to have that target become eligible to receive new connections again. So you could have this persistent quiesce capability so that you will control when you want work to go back to your production site once you re-IPL it. So those are kind of really the two use cases of why customers have asked for that. The final thing I wanted to talk about was some additional support we've done for Rocky Express 3. Hopefully, most of you are aware of our SMCR technology. Essentially, what we've done here is there's something called RDMA, or Remote Direct Memory Access. This is the technology that allows you to configure network interfaces to read directly from memory. So rather than having to copy memory from host OS memory directly into the network interface's memory before getting sent out, we basically just can point to the network interface to a piece of storage directly in the operating system, and that network interface reads directly from it, and the remote network interface can take that data and store it directly into its host operating system memory. Very, very powerful technology, and it's very efficient over TCP protocol, for example. The issue is with this is that it does require application changes, meaning that this is not a typical TCP socket application. This is an entirely different set of verbs in order to be able to take advantage of this, which would require a complete application rewrite in order to take advantage of RDMA technology. So what we did with SMCR is similar to what we did with ATTLS. We made this transparent. So the applications are still your TCP IP socket applications. They're going to do a socket open. They're going to do reads and writes across the socket. Under the covers, what we are doing now is once that connection first gets established, what we will do is now we will send a new option on the TCP original, the three-way handshake, to basically indicate that we are capable of supporting SMC, and is the remote side capable of supporting SMC. If they are both capable of supporting SMC, which is the shared memory communication protocol, under the covers or transparently, we will switch to start using SMCR verbs directly and using that new network interface card that supports this RDMA capability, and start using that directly. From a socket application standpoint, they're still doing TCP sends and reads, but under the covers, we're converting those to be these RDMA verbs that allow us to take advantage of the network interface reading and writing directly into host memory. So that's been around for a while now, but essentially what the original technology, or SMC version 1, it was for layer 2 only. And what I mean by that is both endpoints could not be separated by any type of router. They all had to be on the same exact subnet, which meant you probably had limitations on distance on how far you could do this communication. It also limited, the scenarios where this would make sense to do. With our new technology for SMCR v2, there's something called what we call routable routing. And essentially what that is now we're able to use this RDMA technology over multiple network hops to reach the destination. It no longer requires layer 2 networks. It requires what's called layer 3, which means it's routable. So we can send a packet now using these RDMA flows across one or more routers or network hops to reach the destination. The way that is done is at the network interface card, they encapsulate these packets with UDP and send them across. And so there's just a pointer here that it does use a well-known UDP port, and that if you have any firewalls in your network that suppresses UDP packets, you would need to have it open for this specific port in order for routable routing to happen. But again, it basically now opens up the use cases for being able to use SMCR. So it's no longer confined to your single data center where you use layer 2 networking. It could be now cross data centers where you have to go over one or more network hops. Now this Rocky Express 3 card that it was introduced now and is available in 3.1, and this feature also is rolled back to 2.5. It essentially is a brand new technology refresh. It supports both 10 and 25 gig, and it supports both the non-routable and the routable versions interchangeably. But it does provide improved performance over the previous hardware implementation. With that, I'm going to pass it back over to Sam to finish up.
Okay, so the next topic we have is communication server exploitation of the IBM function registered for zOS. So a lot of words there. What does it mean? Well, back in zOS v2r3, zOS shipped something called the IBM function registry for zOS, which gave us a way as either elements in zOS or even vendor products to store functional usage information in a common place That's the place being the function registry. So a vendor can have a slot and they have multiple products underneath there. zOS has a slot, and in 3.1, ComServer becomes the very first element to use the function registry. So we have slot number 1 in that table for VTAM, oddly enough. So what are we doing with it? In 3.1, we're storing SNA application usage, and I'll get to the why is on the next chart. What are we collecting? We're collecting high water marks for SNA open ACBs and associated session counts. We refresh that every 5 minutes. This hopefully provides you insight into the extent of your SNA application usage. So I talk with customers about SNA a lot, and I find they often do not know how many SNA applications they have, how many SNA sessions they have. You may occasionally get questions from upper management about, what you're doing in your network, and curious about this SNA thing. Does that even exist anymore? Can we eliminate it to simplify? And you may kind of think, well, I don't know that that's possible because we have a lot of SNA. Well, do you? Can you quantify it? And most customers aren't really comfortable with saying what the answer to that question is. The function registry is going to allow you to say, well, I have this many applications, this many SNA sessions, at least from a high watermark perspective. How do you get to this stuff? Well, there's a display FXC command, but more useful, there's something called the FXC print utility, which we provide, and it allows you to view this information. And I really encourage you to do this because you may be quite surprised at the answer, one direction or the other. Maybe you'll find out you have less SNA than applications and sessions than you think you do. Maybe you'll find out you have a lot more than you think you do. And that can kind of help you plan things going forward. This is a 3.1 function, but it was rolled back to 2.4 and 2.5 via the maintenance you see on this chart, and that too. So it's been out there a little over a year. So the output from the FXC print utility starts with just some basic information about which product or element we're looking at, in this case, VTAM. And then here's the actual information itself. There's a block here that's the applications. How many RAPI, record API applications you have, how many APPC applications you have, how many TSO apps, TN3270 apps, and so forth. And then a second block, which is the number of sessions, the number of RAPI sessions, APPC, and so forth. And this is a test system, so all these numbers are relatively modest. In some of our customer systems, I think you may see some pretty big numbers here. I encourage you to take a look at it. If anybody decides to want to pass that along to me, I will anonymize it, but I'll be very curious the kind of numbers you see. Every technical update presentation pretty much has a section on function removals. It's the least interesting, the least sexy thing we can talk about, but it's very important to be aware of these as you get ready to move to a new release. And there are 2 function removals in 3.1. And we're going to talk about these on the next 2 charts, showing the statements of direction that we issued in both cases. So here's a statement of direction almost 3 years ago now, where we said we were going to be withdrawing link station architecture, or LSA, device support. And this really started with the hardware team saying they were going to eliminate the OSA chiplet for OSE. OSE was the OSA chiplet that provides native SNA Ethernet support. And once they decided they were getting rid of it, we followed suit and said that as of 3.1, we would no longer support LSA devices. So 2.5 was the last release to have them. There's also something here mentioned called LCS devices, which is sort of the TCP/IP equivalent. I don't think there's a lot of that used anymore. LSA, in some geographies, it does still exist to some degree. You'll notice on the bottom of the chart, there's a migration health check mentioned that will help you determine if you have any of these devices active. The health check has been out there now for a couple of years, so hopefully you're using the health checker. And if you're using LSA, it should have been tripping on this and letting you know it's there. Sometimes people don't worry about this stuff too much till they get to the point of actually installing the new release. Let me strongly, strongly encourage you to make sure you understand whether this applies to you. The odds are, for the customer set I'm talking to here, that it doesn't, that you maybe haven't had this in many years, certainly don't have any now. But please be aware that this could be a fairly lengthy runway if you have to migrate off of it. You don't want to find this out the first time you IPL 3.1. You want to know it well ahead of time. So if you take nothing else away from this presentation, please just understand this is something you want to investigate before you go to 3.1. The second removal is a little bit easier to deal with, but it also probably affects a lot more people. We issued a statement of direction that same time frame, almost 3 years ago, that said 2.5 will be the last zOS release to provide support for configuring OSA using device link and home statements. Now, understand, device link and home still exists in the TCP/IP profile. You use them to define static VIPAs, but you can no longer, as a 3.1, use them to configure OSA connectivity. You have to use the interface statement. The interface statement was introduced about 20 years ago. So this is not breaking news. And as a matter of fact, as we have added functions to OSA, we always add the parameters to the interface statement, but for a long time now, we've not been putting those on device link home. So if you've wanted to use any of our new features in the last decade or so, you've had to use the interface statement. Hopefully, most of you are there now, but if not, there's a migration help check down there that's going to help you identify if you have these, or you can just browse your TCP/IP profile and tell as well, you will need to eliminate these before you go to 3.1. So another thing to stay in front of, easier to deal with if you have to make some changes than the previous chart, but still, again, something you need to take care of. All right, and we have just a set of charts on some additional information. This is mostly just that information to think about. We have, for some releases now, been maintaining these new function APAR summary web pages. And this is really pretty cool if you like to stay up to date on what new functions we're shipping through continuous delivery. So go to one of these URLs based on the release you're at now. If you're at 2.5, go to that second one. When you get there, you're going to see a list of new functions that are available at that release level. So here's the FTP JES one I talked about as the very first thing in this presentation. It shows you that a link to the PTF information. It's got a link to the doc that tells you how to use it. It, of course, gives you the APAR number and some other information here. And you will see this repeated on this page for every new function APAR that we shipped in that release. So one-stop shopping, very useful. Please go to the URL that applies to you and bookmark it and check it occasionally. We've talked about OSA a few times here. One of my colleagues a little while back wrote a OSA Express Best Practices white paper, and you can see the link there on the screen. This is not a particularly long paper. It won't take you a long time to read, but it has a number of very useful suggestions for making sure you've configured your OSA statements in a best practice manner. So pick that up, take a look at that. Every release, we study the performance of that release, and our customers usually are very interested in this information. It's going to tell you about all kinds of CPU, throughput, latency information for various functions, and it's going to, people typically are very interested in that information. Well, you see this one here is the V2R5 performance summary report. You might be thinking, well, where's the 3.1 one? Well, it's coming. And a matter of fact, if you go to the link at the bottom of the page, you'll see this, and this lists all the performance summaries we had for the various releases we've shipped. You'll notice that the 3.1 still says coming soon. Coming soon in this case is very soon. We expect this to be published sometime in the next couple of weeks. So if you're interested in this, check back in a little while using the URL in the previous chart, and you should be able to get the report at that time. We have a number of digital badges and online courses available. A lot of people find these very useful. The IBM community, I've mentioned a couple times about things being out there. We have blog entries about various things. We include links to videos, just a lot of useful information. It's one of our best ways to push information out to our customers. We are currently working on a survey that we would like to get more information from our customers on how they use certain functions. That will be published on the IBM community. So I encourage you to go to the link you see here, bookmark this, and check this occasionally. There is a lot of useful information posed there. Okay, so please go to the link here, post your session feedback. There's a QR code that will take you there. And of course, the session code is 5K if you just want to go to the website and use that to find it. We really encourage this because it's helpful for planning future GuideShare Europe UK conferences. So please take the time to do this. And that's it for our material. Do you have any questions for me or Mike on any of the material we've talked about in the last hour?
Okay, so everybody can unmute themselves. We have one question from Tony Ames. It's in the chat. Can syslog-d be configured to listen on specific IP address for incoming UDP/TCP messages rather than in iNetAny?
Yeah, yeah. Hi, Mike and Sam. Been a while. Yeah, just sorry,
Hey, Tony.
just extend on that. Syslog daemon can listen on UDP 514, or it sounds like now TCP port as well. Can it listen on a specific Viper address? Because I think at the moment it only listens on iNetAny, so it can listen on any UDP packets coming on any IP address rather than a specific Viper address.
Yeah, if you, for example, if you use a TCP protocol and you configure syslog to use a TCP protocol, then what you would need to do is in your port statement have a bind keyword for that specific port as syslog is listening on for that dynamic Viper, and the dynamic Viper would then get created and bound to specifically that for syslog D.
Okay, can you do that for UDP as well?
For UDP, you cannot do that, no.
Okay, all right, thanks.
It would just be for TCP.
Okay, thank you.
The presentation will be available on the GSE website after the event.
Yes.
And any other questions? Okay, I think that's all, Sam. Thank you very much for both Sam and Mike. It was really useful, and hope to see you again soon. Thank you.
Thank you.
Thanks. Bye.
Thanks, Milt. See you later.